In the previous video, I have told you, or I have solved the delta function potential for the bound state, and now I am going to solve it for the scattering state. So basically, the scattering state means that the energy is greater than 0. So the Schrodinger equation is minus h cut square over twice m d2 psi dx square minus alpha del x psi x equal to E psi x. Now, as I told you earlier in the previous video, that the delta function potential is a infinite pump with an area of unity at x equal to 0, which has only value infinity at x equal to 0, and otherwise it is 0. So as in the previous video, we are going to solve the problem for two regions, for x is lesser than 0 and for x is greater than 0. So for the first region, x is lesser than 0. So now, as you can see, for the first region there is no potential. Basically V is potential is equal to 0. So minus h cut square over twice m d2 psi dx square is equal to E psi x. Okay. So now d2 psi dx square is equal to minus twice me over h cut square psi x. So I am going to choose a constant now, k is equal to root over of twice me over h cut square. Now in the here E, the energy, is greater than 0, so the whole quantity is real and positive, so that's why I am choosing this. So d2 psi dx square equal to minus k square psi d2 psi dx square plus k square psi is equal to 0. Now we have to solve this ordinary differential equation. You can choose psi as e to the power mx, where m is any kind of quantity. It might be complex or positive or negative, real. Okay, so double differentiate it with respect to x gives us m square e to the power mx. Now by putting this value in this equation, differential equation, we get is m square e to the power mx plus k e to the power mx is equal to 0. So m square plus k square is equal to 0, or m square equal to minus k square, or m equal to plus minus ik, where I is imaginary number root over of -1. Okay, so we got two solutions. One is e to the power plus ikx and another is minus e to the power minus ikx. So by combining these two, we get solution like this. Okay, where a and b are two constants. Now here we cannot cancel any of this, because any of these two constants are not blows up. So for x is lesser than 0, the solution is this, and for this second region, the solution will be c to the power x, same with two different constants. So now the solution for psi is a e to the power ikx plus b e to the power minus ikx for x is lesser than 0, and c to the power ikx plus d e to the power minus ikx for x is greater than 0. Now here we have 1 2 3 4 5 constants to find. Okay, so we're going to use the two properties of the wave function. One, psi is always continuous, and another one is d psi dx is continuous except at points where the potential is infinite. Okay, so now we are going to use this as this is the boundary between x is lesser than 0 region, x is greater than 0 region. So psi must be continuous between this. So I am going to put psi for x is lesser than 0 region at x equal to 0, and psi for x is greater than 0 region putting x equal to 0. So they are must be equal as the psi is continuous. So by putting this, what do we get? So for the first property, that psi must be continuous. So psi at x equal to 0, a e to the power 0 is 1 plus b for x is lesser than 0, and psi at x equal to 0 for x is greater than 0 is c plus d. So as that is the psi is continuous through the boundary, so these two must be equal. So I am denoting these as psi minus for the x is lesser than 0 region and putting it psi plus for x is greater than 0 region. So psi plus is must be equal to psi minus. So a plus b equal to c plus d. Now for the using of the second property, as I saw in previous video, that minus h cut square over twice m d2 psi dx square minus alpha del x psi x e psi x. What we are going to do, that we are integrate this equation from minus epsilon to plus epsilon, where epsilon is a greater than 0 quantity, and then we use limit epsilon tends to 0, which makes the equation as it is. It does not change the definition of the equation. So by doing this, we get d psi dx del d psi dx is equal to minus twice m alpha over h cut square psi at 0. Now I am elaborate this thing how come I have evaluate this thing in the previous video, so you can check it out. So d psi dx is basically the difference between the two regions. So basically psi x a to the power ikx plus b to the power minus ikx is for x is less than 0. So I am going to differentiate this with respect to s. What we get? Ik a e to the power ikx minus b e to the power minus ikx. Okay, now putting x equal to 0, at x equal to 0, what we get? We get ik a minus b So denoting it by d psi dx minus, and for the x is greater than 0 region, we'll get ik c minus d, and denote it d psi dx plus. So putting these values in the equation, this equation, what do you get? Ik c minus d minus ik a minus b is equal to minus twice m alpha over h cut square psi 0. So psi 0, as you can see that psi is equal to a e to the power ikx plus b e to the power minus ikx. By putting x equal to 0, what do we get? We get a plus b. So we are using this value. You can use other than that also, c to the power ikx plus d to the minus ikx. So by putting x equal to 0, we get this term. So now we have to solve this equation. We have those two equations. Let name these two equations 1 and 2. So now we have to solve these two equations. So there are 5 constants, so it is really tough to solve this, and normalization can't help us. Okay, so how do we solve this equation? So let's imagine something, that what does these two equations signifies. Okay, as you can see, a to the power ikx, this is a wave which is traveling from left side to right side, and b to the minus ikx, this signifies a wave which is traveling right side to left side. Okay, and these two also. So if we imagine a wave a to the power ikx which is traveling from left side to right side, okay, so from region 1 to region 2, so we get another wave here, and this will be the transmitted wave, and this wave will be the reflected wave. And now as the wave is traveling from left side to right side, so this does not signifies anything. This gives us a wave in the second region coming towards the first region from right to left, which does not signifies anything. Okay, so this signifies the reflected wave from second region to the first region. So we are going to put d is equal to 0. We can use this thing in another way, like if we choose d to the minus ikx is the incident wave, which is incident from region 2 to region 1, then c signifies a wave, reflected wave from region 1, and this signifies the transmitted wave, and here it will be 0. So by putting, if I am choosing a e to the power ikx as the incident wave, b to the power minus ikx as reflected wave, and c to the power ikx as transmitted wave, okay, and d is nothing. Okay, so what do we get? We are going to put d in d is equal to 0 in these two equations. So from the first equation, putting d equal to 0 for the first equation, we get a plus b is equal to c, and for the second equation, this one, we get ikc minus ika minus b is equal to minus twice m alpha over h cut square a plus b. Okay, let's simplify it. So c minus a minus b minus twice m alpha I k h cut square a plus b. Let a constant b is equal to m alpha over k h cut square. So this becomes twice I beta a plus b. Okay, so the from the third equation, a plus b is equal to c, we get c minus b is equal to a, denoted it as 5, and from the fourth equation, we get c minus a plus b is equal to twice I beta a plus twice I beta b. So c plus b, if I take b common, so 1 minus twice I beta is equal to a 1 plus twice I beta, denoted as 6. So now we are going to solve these two equations. So c minus b is equal to a, c plus b 1 minus twice I beta is equal to a 1 plus twice I beta. Solving this, minus minus minus, these two cancel out, we get b minus, take minus common, twice minus twice I beta, and a, these two cancel out, twice I beta followed by a minus, right. So by solving this, we get 1 minus I beta a, and so b is equal to I beta over 1 minus I beta multiplying by a, multiplying with a, and from this I can easily find c as c minus b is equal to a. So c is equal to a plus b, and a plus I beta 1 minus I beta a. So what do we get? A minus I beta a plus I beta a over 1 minus I beta, these two cancel out, so I get 1 minus 1 by 1 minus I beta multiplying with a is equal to c. So now I have find b and c. Now the probability of a particle which is incident from left side to right side, from region 1 to region 2, which is the probability of reflected back. Okay, probability that the particle will reflected back to the first region will be by mod of a square, which means this is the reflection part and this is the incident part. So this signifies the probability of a particle will reflected back, which is incident from left side to the right side, reflected back from second region from to the first region, is equal to this quantity, which gives us I beta square 1 minus I beta square. Okay, so this gives us minus beta square 1 minus I beta whole square, like this. For the probability of the transmitted wave, that a particle which is transmitted from region 1 to region 2, its probability will be mod of c square over mod of a square, and we get 1 by 1 minus I beta its square. So now these two quantities r and t, if we sum these two quantities, we will get t plus r is equal to 1. Okay, so that is the total probability of the particle, and this is how you can solve the Dirac delta potential for the scattering state. Thank you.